Hello children, today we are going to calculate the electric potential at a point due to a point charge. So point charge means it is the source charge. And here if you wanted to draw this, you can take a source charge here plus Q. The point where this source charge is placed will be taken as the origin. We all know the definition of electric potential. What is electric potential at a point? So electric potential at the point is the amount of work done in moving a unit positive charge from infinity to that point. Here the point is taken as P. Okay. So electric potential at this point P will be the amount of work done in moving a unit positive charge from infinity to this point P. So unit positive charge means it is the test charge. Okay. Point P, we can note it down here. Unit positive charge means it is the test charge. It is placed at infinity. So now these two charges are of the same kind. So what happens is when this test charge is in infinity, it does not experience any repulsive force because there is no influence of this source charge plus Q in this point. So now if you wanted to check the field lines, you can draw it like this. There will be, as long as there are field lines, there will be the experience of the repulsive force, right? So now slowly we can move this charge to this point A. As soon as this charge reaches this point, it experiences a repulsive force, right? Okay. So now what should you do? But still you wanted to bring this charge to this point P, right? So what you have to do is you have to apply force such that the repulsive force is overcome and the charge is moved to the point P. So you are doing some work. That work done per unit charge is the electric potential and we are going to calculate that. Okay. So yes, consider a point charge Q at the origin. So we are taking Q to be positive. So we wish to determine the potential at any point P with position vector R. Okay, so position vector R means nothing. This point P is at a distance R from the origin, right? So that distance, this will be the position vector for the point P. So for this, we must calculate the work done to bring the unit positive charge from infinity to the point P. So as Q is greater than 0, that is Q is positive, work done will be against the repulsive force. Work will be done against the repulsive force that this test charge is experiencing. Okay. So now let us see here, the test charge is placed at a distance X from O. That is, I told you earlier, this test charge is moved because there is no field, there is only field till here. This test charge Q is moved till this point. Okay. So now from here it will experience a repulsive force. So let us calculate the repulsive force here. We know the famous Coulomb's law with which we can calculate the force between these two charges. Okay. The force between Q and Q can be given as F is equal to 1 by 4 pi epsilon naught. Our source charge is plus Q, capital Q and test charge is small q. QQ by the distance between, now your test charge is here, right? So the distance between these 2 points is X. So it will be X square. Okay. So this force will be repulsive. And this force will try to push the, it will push the test charge away from this point A. Okay. So that is why this arrow is given. So now we have to do work done. We have to do work to move this test charge from this point A to this point B. Yes. And again, Coulomb's law, here we are describing only the magnitude. Okay. The direction is not specified. So vector form of Coulomb's law will contain direction. This is only the magnitude form. So to move the charge from A to B, work needs to be done, right? Okay. So now your test charge is here. You need to do some work to move this test charge towards the point B. So this distance is a small distance. The distance is taken as dx. Okay. So the work done will be taken as dw. dw will be f dot dx. Okay. So as the repulsive force, the force is in this direction, the displacement is in this direction. Dx is here in this direction, and like force is here, right? So what is the angle here? 180. So this will become f dx cos 180. So what is cos 180? Cos 180 is minus 1. So this becomes minus f dot dx. Okay. So this is the amount of work done in moving this test charge from the point A to the point B. Now to move this to the point P, okay, to move the test charge from from infinity to the point P, we have to calculate the total work done in moving this charge from Q to from infinity to P, right? So the total work done in moving charge Q from infinity to the point P. For that, what we will do? We will use mathematics. Our famous integration will come in to help. Integration is repeated addition. I hope you all know that. Divide into equal number of subdivisions and integrate so that you get the total product, total sum. Okay. So now integration between infinity to the point P. Now this point P is at a distance of R from the origin. So the upper limit will be R. Lower limit will be infinity. Okay. So now you have to write integration of infinity to R f dx cos theta. That f dx cos theta was minus f dx cos 180, right? So we'll write this minus f dx here. Okay. So now substitute the value of f. Take the minus outside. Integration of infinity to R 1 by 4 pi epsilon naught q divided by distance was x square, right? You can see here distance was x square. Okay. So and here dx. So now if you can see that only the with regard to the distance you are calculating the work done, right? Magnitude of force will remain constant. So this q are constants. 1 by 4 pi epsilon naught is constant. You can take all of them outside. q by 4 pi epsilon naught integration of infinity to r 1 by x square dx. Okay. So now this can be written as 1 minute. Okay. This can be written as minus q by 4 pi epsilon naught integration of my infinity to r x power minus 2 dx, because 1 by x square is equal to x power minus 2, right? Now you have to integrate. I hope you all know how to do integration. So integration of x power n dx, this is from grade 11. Dx will be equal to x power n plus 1 divided by n plus 1. So integration of x power minus 2 dx will be x power minus 2 plus 1 divided by minus 2 plus 1. So it will be x power minus 1 by minus 2 plus 1 is minus 1. So it will be minus 1 by x, because x power minus 1, when it comes down, it is 1 by x. So minus 1 by x. I hope this integration is clear to all of you. Now we will substitute this minus 1 by x in the place of our integration. Okay, so this will become equal to minus q by 4 pi epsilon naught minus 1 by x. Limit is infinity to r. Okay, So you should, I think you will know that you have to substitute, how to substitute the limits and all, right? We'll write that here. So W will be equal to minus QQ by 4 pi epsilon naught 1 by minus 1 by X. Limit is infinity to R. So you have to substitute the upper limit first, followed by the lower limit. Before that, here there is a minus, here there is a minus. Minus into minus will become plus. Okay, so it is QQ by 4 pi epsilon naught now divided, into upper limit, right? 1 by R minus 1 by infinity. So number by infinity is 0. Okay. So now that concept, when you apply here, you will get it as QQ by 4 pi epsilon naught 1 by R. Okay, so that is QQ by 4 pi epsilon naught R. This is only the work done, right? Now you need to calculate the work done per unit charge. So work divided by the charge will be equal to the electric potential at that point. Okay, so this is W. V is equal to, we know that V is equal to, WKT means we know that V is equal to W by Q. We have calculated the W divided by the test charge, okay, unit positive charge. So W is QQ by 4 pi epsilon naught R. So divided by test charge Q. That will be equal to QQ by, 4 pi epsilon naught R Q. QQ cancel. So you will get it as Q by 4 pi epsilon naught R. That is V is equal to Q by 4 pi epsilon naught R. This is the electric potential at a point due to the point charge. So from this you can observe that V is inversely proportional to distance. That means if the distance increases, what will happen? Distance increases, potential will decrease. Distance is less. If we are closer to the charge, potential will increase. Okay. So if you represent this graphically with distance in the x-axis and potential in the y-axis, the graph will be like this. Okay. So the potential will keep decreasing as the distance increases. So and this potential will depend upon the distance of the observation point from the source charge. Okay. So the point, it depends on the point. Okay. So if this is the point, so it will depend only on the distance, not the direction. So no direction involved. No direction involved. So these type of graphical questions will be for MCQs or 1 mark. So you have to understand and learn the graphs. All the graphs in the NCERT are important. Okay. And distance, only distance of the observation point. Required. Okay. So this is a electric potential is a scalar quantity. I hope you are clear with how to derive electric potential. First calculate the work done. Diagram should be like, you should be very clear with the diagram. Then you have to calculate the work done, then find it for the unit positive charge so that you get the electric potential. So if you have any doubts in this, please raise it in the comment section. We will revert back to you with the answers. Thank you.